born. All right, hello. It looks like we're solving properties of rational exponents. Okay, I'm going to start this off by saying I don't know if this is the same one you got in your preview in class because I was away from my room. Hopefully it is. If not, you'll just get another example that you can put on your note card. So that's cool. Anyway, it says simplify, write your answer with positive exponents, no decimal fractions. Yes, that is correct. No decimal fractions. You should leave them all as improper fractions that are positive. Okay, so this is like two separate problems. All right, so let's think like that. Okay. All right, so the first thing that we got to know is that this is all cubed, okay? You can attack this problem a couple of different ways. I'm going to attack this as I'm going to distribute this 3 to all 4 exponents, okay? Now, anywhere you don't see an exponent, there's like an invisible 1, okay? So what this turns into is x to the 7/5 times 3 over 1, because remember power, you multiply, times y to the 1 times 3, over x to the 1 times 3, y to the 4/3 times 3 over 1. Okay, so when you're multiplying fractions, it doesn't matter, like if you have common denominators or not, you just multiply across. So this is going to be x to the 21/5, y to the 3rd over x to the 3rd, y to the, those are going to cancel, so that's just y to the 4th. Okay. Now, again, there's a couple different ways you guys can attack this. What we need to do is 21/5 minus 3. I'm going to do this in the side over here. 21 over 5 minus 3 over 1. The problem is now you need common denominator. I'm going to multiply this by 5 over 5, which is going to become 21 over 5 minus, what would that be, 15 over 5? That works. Okay, so this becomes x, I don't know why I picked brown, x to the 21 over 5 minus 15 over 5, okay, because that's this. And then that's y to the 3rd minus 4. Okay, some of you might not be taking that step, and that's fine. So then next, we would simplify that. That becomes x. 21 minus 15, what is that? 6 over 5, I believe, hopefully. Yes. Y to the negative 1st. Okay, so now you got one last thing, because it said positive exponents only. To get rid of the negative, you put it in the denominator. So your final answer is x to the 6 over 5 over y to the 1st, or just y. And that, my friends, is your final answer. We're going to go ahead and circle that. All right. The next one, this is x squared times the 3rd root of 64x to the 6, y to the 3rd, z to the 6 over y squared. Now, you have to know that the cube root really means, let me finish writing this out, y to the 3rd, z to the 6. That means you're raising it to the 1/3 power over y squared. Now, you can just take the cube root straight away if you wanted to. But I think this will help you guys with power rule, because again, that means you're distributing that 1/3 to everything, including the 64, and then all of these exponents. All right, so what this means is we got x squared. All right, the cube root of 64 is 4. All right, I'm going to actually write out all my steps. 6 times a 3rd, y to the 3 times a 3rd, z to the 6 times a 3rd, all over y squared. That becomes, I'm going to move the 4 out in front, x squared times x, that becomes another 2, y to the 1st, and then z squared. Yep, that's all fine, all over y squared. All right, same thing here, that's a 4. X squared times x squared is x to the 4th, because you're adding, not multiplying, okay. Y to the 1st over y squared, same rule as before here. That's just, we know the y is going to be in the denominator to the 1st power. Doesn't matter if you write the 1 or not, and then the z squared just stays on top. And that right there is also your final answer. So again, there are multiple ways you guys can solve these. Totally up to you. You do have a little bit of fraction work here. This is where mostly your fraction stuff comes in. Yeah, if you need help with fractions, go Google Khan Academy or something. Good luck. Bye.